Idea of ANOVA. Our goal is to compare the means of several groups. We're going to do this by analyzing the variance between each of the groups and then that random error or variability within each of the groups. So let's check out how to do this in practice using our calculator. First thing you need to do is enter the data just like we've done in the past using stat, edit, and then put the data in our list. So stat, and then press enter on edit. Now I've already entered the data. If you want to pause and make sure you can enter the data in your calculator, do that. Notice list 1, I have all the data for this first group, below average, 29, 42, 38, so on. 29, 42, 38, and so on. Above average data I have in the second list, and then, average is in the second list, above average is in the third list. So take a moment, make sure you have your data entered, double check your data entry so we all get the same answers. Once your data is entered, we're going to run ANOVA, so that's step 2. We're going to go back to stat, and then over to tests. And this is one of our last tests. I'll push the up arrow to get down to the bottom there. The last test is ANOVA. Press enter on that. And we need to explain which groups or lists we want to compare. In this case, we have 3, but it could be as, 5, 6, 7, lots. You could have data in several different lists. So ours are in list 1 through 3 in this example. So I'm going to press second. And then number 1, so you notice that it has a little blue L1 up here to say list 1. Need to separate with a comma, that's above the 7, remember. And then second, number 2 to get list 2, comma, second, list 3 to get our above average, our third group. So once we have that, let's press enter and check out the results. So the first part, F, is going to be our test statistic. So on our chart, and I'm going to type these because my pen tool doesn't work so well when I've got the calculator going. So this is our test statistic, 16.9615. I forgot my 1 here. There we go. And then you look at the next piece, has our p-value. So our p-value, don't write down 4.1293. Remember, that's times 10 to the negative 5th. P-values are probabilities. They must be between 0 and 1. So don't forget that scientific notation here. So I'll add that in. As our 4.1293 times 10 to the negative 5th. Then we have broken down by contributions by our factor, and you see the little down arrow, we can scroll for contributions by the error. So let's look at the factor first. It gives us degrees of freedom, which makes perfect sense here to be 2. If you think about our formula for degrees of freedom, I'll write it in. It was how many groups? We have 3 fitness levels we're comparing. So 3 minus 1, so number of groups minus 1 is our n minus 1 for factor, which gives us a 2 that's showing up on the calculator. For our sum of squares, they give us that calculation of 672. And then mean squares, remember mean squares is sum of squares, so 672 divided by degrees of freedom, which is 2 in this case, and that's where they're getting the 336. So that's our information for the factor in this case. Now if we scroll down over here, we can get information for our error term. You'll notice the heading changes to represent error. Gives us our same pieces of information, degrees of freedom, sum of squares, and mean squares. So let's jot down some of that here. So our degrees of freedom is 21. So 20, and again, reminder where they get 21. It's our total number of observations, 24. That's our N. We had 24 guys in the study, minus number of groups. We had 3 fitness levels, which is where they're getting that 21 degrees of freedom for the error term. The sum of squares for the error term, they give us 416. The mean squares for the error term, they give us 19.8095. And a reminder of how they got that, that's our sum of squares, 416, divided by the degrees of freedom, 21. Then our values for the test statistic, just leave that blank in these columns. P-value, leave that blank. Mean squares total, leave that blank. But let's fill in the values here for total. So they don't give that on the chart, and this SXP, just ignore this value for now. We're not going to use that for anything in this class, so I don't want to get into that. Our total degrees of freedom was our total number of observations, which was 24, minus 1 equals 23. And you'll notice that property of being additive. 2 plus 21 is 23. And then same thing, our sum of squares total is the sum of squares factor plus error. So we get our 1088 for our sum of squares total. One more comment before we look at writing this up fully and formally. For the test statistic here, and you might want to jot this down in your notes, the 16.96 we got from doing this ratio, the variability explained by the factor over the error. So if you take 336 divided by 19.8, you're going to get something close to this 16.96. All right, I'm going to close out the calculator now that you know how to use that to find our mean squares and sum of squares and all those calculations on your calculator. And let's check out how to formally write up this test. So we've got all the information we need. Now the write-up is going to be very familiar to what you've seen before. So our first step to write up this hypothesis test, we need to state our null and our alternative hypothesis. Our null hypothesis, since we're talking about means, we need to have our 3 means in here, mu1, mu2, and mu3. And feel free to label these mu BA for below average, A for average, and AA for above average, whatever subscripts you want to use to distinguish those 3 groups. Now remember, our null hypothesis always has this equal to sign in it. So our initial assumption is that fitness level makes no difference. The mean recovery time is exactly the same for all 3 fitness levels. I'll put that over here as an aside. Average recovery time is same regardless of your prior fitness. Okay. And then our alternative, this is going to look a little different. This is called a global alternative. It's very general. It can mean lots of things. Basically, it's just the opposite of HO, the opposite of them all being the same. Could mean lots of things. It could mean the first 2 are different, the last 2 are different, all 3 are different. Could mean anything. So lots of different combinations there. So we're going to carefully write that here, actually in words, not even using symbols here. So I'll just say, not all mu I are equal. Or in other words, there's a difference somewhere in the average recovery time. Fitness has some impact. We can't say exactly what it is specifically with this test, but we're saying they're not all the same. Fitness is having some kind of impact. Fitness has some impact on recovery time. Okay. So be very careful to write your hypotheses exactly this way. Don't put it in, don't put any symbols down here for HA. You're just saying there's a difference somewhere. We can't specify exactly what that is. Okay, and then the next few steps are going to be easy for us. We've already done the work. We need to say our test statistics. So that was F, that was our ratio, if you remember, of explained by the factor, so our 336 over unexplained, the 198095, and might be a little different because of rounding, but you should get pretty close to that 16.9615. So this is kind of telling me in a way that the variability coming from the factor is almost 17 times more than the variability that's random and unexplained within the groups. The next step, we need to find our p-value. And for this class, we're just going to read that from the calculator or have that given. So we saw that was our 4.1293 times 10 to the negative fifth. So really, we're going to, and again, in this class, we're letting the calculator do all the work for us. Interpret the p-value. That's always in terms of the null hypothesis. So our null hypothesis here is saying average recovery time is not influenced by your prior fitness level. Those means are all the same. So if prior fitness level has no impact on recovery time, okay, so again, that's what we mean by HO being true in context. Then these are our chances of seeing our data. So if that's true, we would see data like ours or more extreme. This percentage of the time, so multiply this by 100 to make it a percent. So 4 times 10 to the negative third, or 0.00412993% of the time. And then let's make our conclusion. Remember, conclusion is always in terms of HA, going back full circle to our research question. So p-value in terms of HO, conclusion in terms of HA. So under the initial assumption that prior fitness level doesn't do much for you, we're rarely going to see this data. So we have very strong evidence that fitness level, so we're thinking again, what does HA mean? That's our HA is saying not all mu-I are equal, or fitness level has some impact on recovery time. We observed that it kind of looked like more fit, shorter recovery time, but we can't be that specific. All we can say is there is some impact. So there's very strong evidence that fitness level has an impact. Don't give details because we don't know them, on recovery time. And that's our HA in context. All right, we're going to do one more example in the last video, and this example will be important. You need to be able to work these problems without your calculator as well. So that will be shown in our next example.